All right. I just want to talk about blockchains. I know blockchains are moving from their peak a couple of years ago when everybody was jumping into it because the price of Bitcoin was insane. Now it's sort of calming down to be a little less new and exciting, but I think it's going to become a standard thing we need to know how to handle. So if you don't know what blockchains are at all, there's a very nice demonstration of it here where you just have a simple blockchain you can run here. So if I put in data like Sam has 10 coins, since I've changed the contents of this block, it turns red because it hasn't been mined. So if a block hasn't been mined yet, you can add data to it. When you're ready to seal it, you mine it. And so you change this nonce value, this one number you change at random until you get it to have a hash that starts with a certain number of zeros. And that's the difficulty of the blockchain. So now that it's found a solution with that nonce value, this is now a mined block and it turns green. And now you can go to the next block where I can say Sam gives Bill 5 coins. And then this one gets mined by somebody. And after this is mined, you can then go to this one. Shu gets 5 coins and mine that. And the point is, the reason it's a chain is each block includes the hash from the previous block. So if you change anything, like if I try to change this to 100, then all the blocks no longer match. They all turn red. So if you want to verify the chain, all you have to do is verify the latest block, and that proves that all the chain up to that point is correct. And that's the point of it. So this is designed to keep track of money. You can have a list of who had the money and where the money went, and it's all unchangeable. And this turns out to be appropriate for an event log, a series of transactions. If you have a supply chain where the supplier is supposed to give me aluminum, the supplier is supposed to give me wire, and the supplier is supposed to give me refrigeration parts, and they all have deadlines, and I want a permanent record of what contract we agreed to and when you shipped stuff and when I agreed that I really got it and so on, so that if it turns out that people are late and they owe me penalties or something, that all that is very clear and everybody agrees. So this is a way to have a database where many people can write to it and there's a permanent record, but nobody can change any of the old records. So it's good for financial ledgers or anything else where you might have to go to court later and fight about what happened here. There has to be a very clear record of exactly what everybody said. Anyway, that's what a blockchain is. And you can play with this simple demo. And there's some flags you can find here to show that you've got that working. And then you can set up a real blockchain. Now, Hyperledger is IBM's entry. IBM is a big entry in blockchains, and they have developed a whole suite of blockchain products for real business cases. And one that I used before was Hyperledger Composer, which used to be just a simple blockchain you could make right in a browser, but for some reason, they've taken that away, the playground for Composer. So the next simplest one I found was Aroha, which is designed for mobile applications. And so it's again shrunk down to be simple. So you can install it on your Debian server, you install Docker, you put on an image that runs, one image that runs a PostgreSQL database, which is where the data is going to be stored, and then another one which runs Aroha, this Aroha machine, Hyperledger Aroha. So once you start them, they communicate with each other and over the local network on port 5051 and so on, 50,051. And now you can run the blockchain. And it doesn't give you a GUI, and this I could find, but you can run it just in a command line here. So you choose off a menu, you can make a transaction, a query, or a status request. So you can create a transaction, and you're going to create a new asset. Your blockchain exists, but it doesn't have any information about coins until you create it. So you create something called cool coins, and you give it a precision of 2, which means it has 2 decimal places. So you can have units of 0.01 cool coins. Then you send that transaction, and it will run the transaction and tell you if it worked. Congratulations, your transaction was accepted. And every transaction has a number, a hash number to uniquely identify it. And it's stored on the blockchain. So you can always go back and find out what was done with the money. Now you can make a new query. You can issue some cool coins now that they exist. You can issue an asset. You can check your balance. You can issue 1,000 cool coins. Then you can make another account, send the coins over there, and so on. You can see how a blockchain works in practice. This is just a structured database, but it has this high integrity feature that everything is verified and cannot be altered after it's added to the chain. All right, and then you can hack PWH coin. This was a cryptocurrency invented by some people on 4chan as a Ponzi scheme, and it was mostly intended to be a joke, but people invested almost $1 million in it. And in addition to being financially irresponsible because it was a Ponzi scheme, it turned out to have a bug and you could just steal the money. And the cool thing about blockchains is everything's public. So you can totally reproduce the real attack that stole $1 million from this thing. So, and what's even more great is because blockchain cryptocurrencies were so wealthy a few years ago, there was a ton of money for developers, and they developed all these cool training tools to learn blockchains, like this one, Remix. Ethereum is the cryptocurrency framework that lets you run code on the blockchain. So you can do more things than cryptocurrency. You can run code. And that was the point of it. You can make a contract, which is code that runs on the blockchain, so that it's all the management is done by software that is distributed. And the original plan of this was that you would escape all laws. You would not be eligible to banking laws or any other laws, because technically your code would not live in any country. However, when the first prototype did in fact get hacked and crash, which was the DAO, the Digital Autonomous Organization, they did in fact punish the developers in America and made them pay for stuff. And it turned out the law does not recognize your argument that because it's on the blockchain, it's outside all legal structure. The fact is the humans do live somewhere and are still subject to some law, even though they didn't like that very much. So anyway, I want to go to Solidity and File Explorer. This thing simulates an Ethereum blockchain in the browser. And so what it's done, I'll try to make it big for this creates, it's not connected to the real Ethereum blockchain, and there's no real money in it, but you can run all the math of a blockchain right in your browser without even a network outside it or anything. And so you can code stuff and test stuff. So here we are with the default stuff it gives you. And here's something left over because I've run it already in this browser before, PWOH coin. And I'm going to try and delete it. Yeah, delete. There we are. Good. Because I want to start over from fresh. Okay, this is the 4 stuff they give you by default. And I want to just create a new one. So I'm going to go get the source code from here. This is the original PWOH coin source code. It's just about 300 lines of code in this language called Solidity, which is pretty much like JavaScript. There are 306 lines of code in the clipboard. Now, I'm just going to follow my instructions because this one is fun. Hit the plus and put it in. So the plus will make a new file. I'll call it POW.sol. And I put in all that code. Okay. Now, I have to compile the contract, which is the 3rd icon. Okay, so that is here. That compiles my contract here. And down here are messages that show you the status, if there is any, and it looks like it didn't compile. Now it has compiled, and now I have a contract called Ponzi token, is what they called the token of currency they created here. Now I deploy it, and the orange deploy button. So deploying means you put it on the blockchain, which is this one, I think. Yep, deploy and run transactions. Now deploy. So now it has gone onto the blockchain, and I'm using a simulated JavaScript blockchain, so you can see here the accounts. There are 10 or 15 accounts created with these random account numbers, and they each have 100 Ether, which is an amount of money. And this first account has a little bit less than 100 ether because everything you do on the blockchain costs money. They call that gas. And this tiny fraction of an ether that I spent is the gas I paid to deploy the contract. And by default, it assumed I was paying from the first contract. So I've now deployed it out so it can be used by other people. And now the methods are down here. I can even use a simple little GUI. This is the Ponzi token contract, and here are the things it can do, like fund and withdraw money and transfer money. Those are things you can do with this financial instrument. All right, and so now I want to fund 50 ether, so it's 50 and fund. So I go up here, here's my account number, and I'm going to put in 50. Way is a tiny amount of money used for paying gas. Ether is the big money. I'm going to put 50 out of my 100 ethers into the contract with fund. So that is a transaction, and the check mark tells me it worked. So now, if I look at my balance, I'm now a little below $50, 50 ether here. And the fund has that money. All right. Now, I'm going to add another investor with 1 ether and fund, okay. And this, I have to be careful to do it exactly right because we are going to steal all the money. So I have to use the second account and put 1 ether in the fund. So I switch to the second investor and I put in 1 ether. And I use the fund button again to put 1 ether in there. So now I have 2 people that have put money in the fund. The first one is putting 50, and the next one is putting 1 ether, and all the rest of these still have their 100 because they haven't done anything yet to spend any of their money. Now, okay, what I want to do is transfer funds, and I'm going to exploit a bug in the system, and we're going to end up withdrawing money from an empty account. So I approve a withdrawal. So I want to get the third account and copy it, and then go back to account 2. I'm going to start with that much. So I choose the third account, and I copy the account number, and then I change back to account number 2, which is the one that's going to pay for this transaction. Okay, now I go to the approve button and I put the copied address in spender. So I go down here to approve, there, and I put the copied address in spender, and I put in a value of 1 for 1 ether. All right. Right. I do the transact, and now if I check the balance of account number 3, it doesn't have any money yet. So let me run this. So I do this transaction, and the transaction succeeds. Okay, but all that did was approve a transaction. It didn't actually move the money yet. All right, now this is the hack. I now transfer funds from the contract into account number 3, but I'm going to move ether into account number 2 from account 2 to the contract address. And what happens is, because of a bug in the code, it's going to get confused and subtract the money from the wrong account. So I have to get account number 2 in the clipboard and go to transfer from. So it's account number 2. Okay, put it in the clipboard. Now I go down to transfer from, which is here. Okay. And I put it in the from field. Okay. In the from field, I put in that address. In the to field, I put the contract's address itself, which is here. All right, and I put 1 here, and now I perform the transaction. And that worked. No, looks like something didn't work. We'll see. Oh, I forgot. That's right. I forgot. I had to make an adjustment before I did that. Put in a value of 1. Now go back and select the third account. Okay. Okay. I might not be, this is a little complicated and I may not succeed, but I think I will. There's the third account is where you choose from up here. And now you perform the transaction and it succeeds. And this is what I wanted to do. I now managed to fund money into the account and it drew it from the third account, but the third account had a balance of 0. So now if I go to balance of old, I can view the balance of this account here, number 3. And if I've done it correctly, that person just stole all the money. So let's see, balance of old, paste, call, yes. This now has an unthinkable huge amount of money. I've taken a 256-bit integer that was 0 and subtracted 1, and it has rolled over to the largest possible value. And this is a real attack that somebody made $1 million stealing all the money out of the fund a while ago. And you can see if you want to go down here a little bit lower and it shows you exactly what the error was in the code. The point is they had a couple of different ways to move money from one account to another, and the functions have defects, so it subtracts from the wrong account under certain conditions. So that was pretty fun. I think it shows you the many flaws of cryptocurrency. And one thing about cryptocurrency is that all the cryptocurrency exchanges keep getting hacked and the money keeps getting stolen over and over and over. They're really very risky to involve yourself with. I'll save that one.